All right, let's dive into something pretty cool today. We're looking at an idea from the book Math I Reboot, and it's a big one. What if all that struggle with math wasn't because you're bad at it, but because nobody ever taught you how to actually see it? Let's get into it.
You know that feeling, right? Where math just suddenly stops making sense? The book points to Math I as that classic moment, that wall you hit where everything becomes abstract and just, well, impossible. If you've ever felt that way, trust me, you're in very good company.
So what's the fix? The whole idea behind Math I Reboot is about flipping a switch in your brain. On one side, you've got the old way, just memorizing formulas like they're magic spells you don't understand. But on the other side, there's the new way, learning to see math as a language, a system that has a logic you can actually read.
So, let's dig into this problem. But we're not going to frame it as some kind of personal failure. The book calls it a math glitch, kind of like a system error in how we were taught to think about it in the first place.
And this right here, this gets to the heart of that glitch. We're taught to look at math and see this scary wall of symbols. But the real problem, the book argues, is that we're so focused on just memorizing the rules that we never stop to understand the structure. You know, the why behind it all.
Okay, but it's not all bad news. Far from it. Now we get to the turning point. The book offers up a solution, a total reboot for how we see math.
And this quote just says it all, doesn't it? Math I is not a subject for memorizing formulas. It is a subject for learning how to see. Let that sink in for a second. That one idea changes everything. The goal isn't just to get the right answer anymore, it's to understand the beautiful patterns that get you there.
So this all sounds great, but what does learning to see actually look like in practice? Well, in this next part, we're going to install a couple of upgrades using some great examples straight from the book to show you what I mean.
Let's start with one that I bet a lot of us still have nightmares about, factoring. But look at how the book reframes it. It's not some random calculation. No, it's a process of recognizing a structure that's already hidden inside. It's like being a detective looking for clues.
Okay, check this out. We've got x squared plus 7x plus 12. Instead of just guessing, we're on a mission. We need to find two numbers. What are the rules? Well, they have to add up to 7, and they have to multiply to make 12. And when you look at it that way, it's a simple puzzle. The numbers, of course, are 3 and 4.
And boom, there's the payoff. The whole thing becomes x plus 3, x plus 4. We didn't just solve a problem, we revealed the hidden structure. We've basically learned how to read that polynomial.
All right, on to our second upgrade, quadratic functions. Forget the scary formula for a second. The book wants us to see it as a picture. And what's it a picture of? It's a picture of how change itself is changing. In other words, acceleration.
To see this, let's just take the simplest quadratic function you can get, y equals x squared.
Now really look at that last column, the change in y. When x goes from 0 to 1, y goes up by 1. But when x goes from 1 to 2, y jumps up by 3. And then from 2 to 3, it jumps by 5. You see that? The increase isn't steady like a straight line. It's getting bigger and bigger. It's accelerating. And that's the story the curve tells.
Okay, this is all really interesting, but you might be thinking, why does this matter? When am I ever going to use this? Well, this next part is all about bringing it into the real world with a super practical example.
We've all been here, right? Trying to choose a phone plan or a gym membership. Plan A has a low startup fee but costs more each time you use it. Plan B is the exact opposite. Math lets us turn this real-world choice into simple expressions we can actually compare.
So how do you decide which one's the better deal? It's actually a pretty simple process. First, you build the expressions for each plan. Then, you set up an inequality to ask the real question. Under what condition is plan A cheaper? And finally, you just solve for x, and the math gives you a perfectly clear answer. Plan A is only the better deal if you use the service less than 10 times. That's the tipping point.
So let's bring it all together. We're talking about a whole new empowering way to look at math. Your system is officially rebooted and ready to go.
I really love this quote from the source. Once you begin to see why something works, mathematics no longer feels like a cold collection of symbols. It really captures that feeling of transformation, doesn't it? It's about moving from being scared of math to being fascinated by it, all by understanding the why.
And that's really the ultimate takeaway here.
The whole Math I Reboot idea isn't about becoming a math genius overnight. Not at all. It's about building that foundation of confidence, getting to that aha moment where math finally clicks, where it feels like something you can actually read and understand for yourself.
So, I'll leave you with this final thought. If you stopped seeing math as just a bunch of random rules to memorize and started seeing it as a language you could learn to read, what new things could you understand about the world around you?